everybody, I am Chandra and this video is about logistic regression modeling in data science. So let's look at this. So in this video we have an agenda of how to perform logistic regression and also a Poisson regression. So let's begin one by one. In the logistic regression is a statistical method used for binary classification problem where the outcome variable is categorical with two possible outcomes. So what does it mean? Logistic regression is a statistical method used to model the probability of binary outcomes like a 0 or a 1. You can say yes or no, true or false. It's widely used in various fields including machine learning, healthcare and finance. So first we have to, as in the data science, first we have to prepare our data and then the model building and then the model evaluation. So let's see our logistic regression practical example here. In this model we just classify thing in the binary format like in a true or false. So we have a scan SK linear model, that is logistic regression, that will predict the value. We are using the random numbers from this here and splitting the data and modeling this, and then we are training by fitting the training as in the previously we do. Then we are predicting and it will give the accuracy score, confusion matrix and classification report. So let's see what the accuracy it will provide. So it have the precision of 0.60, that is of 60%, and first 100% also, as FS score is also 0.75, and here we have accuracy 0.80. You can have you can see the output here. Okay, so the next is Poisson regression. Is used as in the definition, it is used to model count data and contingency table. It assumes that response variable follows Poisson distribution. So what is Poisson regression? It is also a statistical method used to model count data. Okay, it's particularly useful when the dependent variable represent the number of occurrence of an event within a specific interval, such as the number of calls to a call center in an hour, for example, the number of accident at an intersection in a year, or the number of defects in the manufactured product. Okay, so basically it is used for that. So it will give the result of coefficient, p values and deviance. uh, if the variance of the response variable is greater than its mean, the Poisson distribution may not be appropriate. In such cases, considering the negative binomial regression model will be good. Okay, so let's look at the practical example of this. So this is the, again we are importing, and this is a SM state model API where we just do the basic fundamental things like fitting the Poisson regression model using this sm.glm. Okay, so let's have an output of this. So here a model GLM, that is a Poisson family you can use, that is using the IRLS method. So according to observation, number of observation are 80, residuals are 70s. All the configuration you can see here. Here the coefficient and the standard deviation error and the z scores you can see. Basically this is used for gain valuable insights and from the data. Okay, so thank you, that's for this video, and see you in the next upcoming session.